So, we will talk about few approaches that are used in the conversation modeling. One is the retrieval based approach, the second one is the statistical machine translation approach. So, I am sure you would now appreciate that all conversation modeling would require a retrieval engine as well, correct. So, what this does is essentially it picks up a suitable response based on how many times a particular response was selected for similar question, and then using a matching features of question and the response, it finds the answer. So, we learned that the use of matching features alone will not be suffice for doing the retrieval based model. So, let's look at least one example of retrieval based model in the subsequent slides. In the statistical model, it treats this as a translation problem in which the model is trained on the parallel corpus of question and response pairs. It is very similar to what we saw in the translation model, and then some models are built using the machine translation approach for conversation modeling. I will not be discussing this part. So, in the IR based conversation modeling, we require definitely a retrieval engine, and then we are going to be restricting ourselves to a short text conversation, and this particular example is taken from this paper published by Jia, Lubb and Lee, and the title is an information retrieval approach to short text conversation. Okay, this was published in 2014. Again, this is a research topic. Okay, so we are going to be having a short text for the conversation modeling. There is about 2 or 3 steps involved in it, not beyond that. The corpus contains different pairs of post comments or question answers. Given a question and the set of documents where you would find the post comments pair or question answers pair, the task is to find the answer from this span of text from the extracted paragraph. Okay. So, if you look at the IR model, so what it does is based on the query that you have, using many of the approaches followed in the information retrieval, you get the list of documents, correct. So, you have the query with certain keywords, and then you start matching the query and the documents which are there in the corpus, and then based on certain ranking mechanism you list those documents. So, in this fashion we are going to be listing certain post comments based on the query given. Okay. So, once the paragraphs where the query matched with the responses, we want to extract only a portion of the text, not the entire paragraph. Okay. So, the portion of the text could be the span of text. For example, assuming that this is your, let me take an example from, okay. So, let us take a small example here to understand what the span of text is, and then we will go back to the information retrieval model for conversation. So, if you search for who is C.V. Raman, okay, you get a lot of documents related to C.V. Raman, right. So, what is that you require? You do not require the entire document that is coming in as links, and you want to read through the whole thing. You just want to get only this, an Indian physicist, right. So, the span of text is when the document is retrieved through the retrieval engine, you get the whole thing, okay, assuming that this is a document. I am simplifying it. It could be a document containing various paragraphs, and one of the paragraphs would contain the answer to the question. So, in this case, let us assume that this is one document, the whole thing is one document, and then the span of text is defined here. So, and this is the answer that we want to get. The span of text here is starting from this word ending here. So, these two words that you want to pick, and then there is a start and there is an end. Let us assume that this is at the 10th word. So, the 10th word to 11th word is my span of text, which contains the answer for this question. I am just making this number up. So, now we know what that span of text means, right. So, given the question and the set of document, the task is to find the span of text from the extracted paragraph. For every given query Q, there could be 0 or more post comment pairs. Okay, this is given, right. The best response to the query Q is picked up based on the ranks of the retrieved pairs using some ranking mechanism. Let us assume that the score is obtained using this, and there could be various scores you would obtain based on the query, post and response pairs. And then you have some kind of a mechanism to score the values, and then once those values are obtained, you pick up the maximum of that score and then say that that is the answer to the query that you have just posted. I am sure you will be able to understand this. I would like you to go and then read this paper. I am not going to be covering the entire paper. I just want to mention that this is one of the idea that is followed in the information retrieval based conversation modeling, where you have the query, you have the paragraph and the rather the post and the responses for the short text conversation. You try to match the query and the post and the response, get a set of the post and the response pairs, and then try to find the score for each of those, right, for the query and the post and response pair. So, if you have more of PR, you will have more of this, based on this retrieval model, you will have more of this, and then you try to find the score for each of this using some scoring mechanism. And then the scoring mechanism is defined as follows. So, what we are going to be doing is we are going to be finding the score based on the features that we have extracted from both query, post and the responses. So, let us assume that Wi is the weight and phi I is the score. Okay. And then what is the kind of features that we would use? We probably would have used term frequency or TF-IDF, or we can probably use some combinations of NER, or we can use POS or the part of speech as set of features and so on. And then using the combinations of all this, we can achieve a score using this model, okay, and then get various scores for the responses that we have picked up based on the IR, and then finally pick up the one which has the highest score, right. So, this query gives you 10 different and so on. Okay. And then use some mechanism using TF-IDF or some scoring mechanism to find out how close query is with respect to the post and the response. Okay. And then use that to get the rank, and then the rank is defined by your score. Okay. So, this is one very simple approach using which you can find the response to a given query. So, if you look at the architecture part of that, as I mentioned, there is an index of post comment pairs that is coming from some corpus, right. And then you have a retrieval mechanism that retrieves the set of post and responses based on the query, and then use a matching mechanism to find out whether how close that query is with respect to the retrieved post comment pairs, and then provide some kind of a ranking as we had done earlier, and finally pick up the best response. Okay. The similarity could be found using a cosine similarity in this fashion. Okay. So, you can find the similarity between the query and the response, query and the post. So, the idea is if the query and the response, if they contain words which are similar, then we are going to have a similarity score attached to the query and the response. In the same fashion, if we have some words which are common to both query and the post, we are going to have some similarity scores which we would be computing, and finally figure out how close the final result is with respect to the query that is given, and that would be chosen as the best response. Okay. So, it is a very simple model where you require the IR engine to get you the top 10 matching documents, and then using some scoring mechanism get the ranks for all those retrieved documents, and then finally get the best response out of that. Again, there is a learn to match and there is a learn to rank that is also part of the system. So, how do you learn this? So, every time when the system picks up the response and then finally the best response is chosen based on the score, user looks at the option that was provided earlier, not just looking at only at the best response, and if the user picks up the second response as the best response, then the learning to match and the learning to rank will start learning that okay, for this type of query user has responded with this score. Okay. So, meaning that I need to change the way I compute the rank. In this fashion, the ranks are changed as well. Okay. So, this is a feedback mechanism that comes from the user. So, when the user ranks are provided, that would get a higher ranking than the system generated ranks. Okay. So, using that approach, then the system would slowly start to learn, and maybe after several responses from the user for this similar query, the user selected response would move up in the rank. Okay. So, this is one model that is followed. I spoke about the learning rank. So, and this is the very simple architecture of the learning to rank model, where you have the query coming in and you have this set of documents, right. So, and the documents are indexed using engines called Solar or other indexing engines. And then you have a retrieval system as part of this. Actually, Lucene is the indexing engine and Solar is the complete retrieval engine which provides all kinds of ranking mechanism and so on. Okay. Initially, when you do not have the LTR, the Solar provides you set of documents with its own ranking scheme. Okay. And then let us assume that this is the post response document that are coming in from the system, and then we will pick up document 105 as the top response for the given query. Assuming that now we have asked the user to rate the responses coming from the system, user picks up that okay, one is not the the right response for me, 3 is the best response as far as I am concerned. And then there are so many users who have given let us say the similar query or the same query, and then they also start to respond that 3 is the best answer and not 105 document is the best answer. We need to let the system learn that part. So, that is where the learning to rank comes in. Okay. So, when the system retrieves that and then user preferences are chosen based on the click throughs or some kind of a rating mechanism that you provide as part of the list. You store the query that is coming in, you store the user preference, there is a Solar ranking or the engine ranking that comes in, and there is a set of results that are coming in. The learning model based on the combinations of all these parameters will start to realize that document 1003 should be on top and not something else. Okay. So, in this case what I have given is document 2005, sorry, maybe we should have picked up this in the beginning itself. So, based on the user preference, document 205 should be coming on top. So, the learning mechanism starts to learn the user preference as well and start to rank the documents in a different fashion. So, user later will not see this rank and start seeing this rank, the documents are ordered in this fashion. Okay. So, this at a very high level what is learning to rank. Okay. So, what are the major drawbacks of the retrieval based model? The post response pairs are canned. It is very hard to customize for a particular text or a requirement from the task, example, style and attitude. So, maybe I will rephrase this, this is fine tuned only for the given task that is given, right. So, you cannot take the same model out and then use it for some other task, it is not going to work, we need to retrain the whole thing one more time. Okay. The use of matching features alone is usually not sufficient for distinguishing positive responses from the negative ones, even after time consuming feature engineering. Okay. So, what it says is the matching features are not sufficient, we need to be able to bring something else as part of this. So, it is again as I mentioned, right, it is based on the information retrieval query and ranking engine, which is based only on the keywords that is picked up from the query as well as from the post and responses. So, the IR based conversation does not have any other mechanism to capture other features. So, we need to find a different mechanism in order to fine tune this. When we look at this model, it is only based on the keywords that are provided, not beyond that, right. So, that is why this is not sufficient. So, we need to look for some more additional features that could be fed as part of the system.